Algebra of vectors. Let's look at scalar multiple. Now remember, when we say vector, we are talking of magnitude and direction. Now when we talk of scalars, just the magnitude. So let's say we want to multiply a scalar, let's say k, which can have any real value, multiplied by, or rather a vector a multiplied by k. Now this can be written as k times magnitude of a in the direction of a, right? So which means what? It is in the same direction. If we multiply it with a negative k, a negative real number, multiplied by a vector, or rather a vector multiplied by a negative scalar. Now this would be minus k times the magnitude of a in the direction of, it should be cap, okay? So this would be opposite direction. So therefore, if we just want to reverse the direction of a given vector, we just multiply it by minus 1. So now the vector is in the opposite direction. If we multiply with 0, we get a 0 vector. That arrow still is required on top of 0. Two vectors a and b will be collinear if b is equal to ma. That means b is a multiple of, scalar multiple of a. The difference between the two vectors is only in the magnitude and not the direction. 3 points A, B and C will be collinear if vector AB and vector AC are collinear. That means AB is equal to MAC. Let's look at this aspect. Let's say we have a vector, right, and we divide this by the magnitude of this vector, right? What does it tell you? What does it mean to you? Basically here, the magnitude of the vector A in the numerator gets cancelled by the magnitude of vector A in the denominator. Remember, vector A can be written as vector A magnitude times A cap divided by magnitude of vector A. Yes, these two get cancelled. So you are left with 1 of A cap. That means 1 unit in the direction of vector A. Now here, of course, since we are talking of dividing, the denominator cannot be 0. So which means magnitude of A, vector A, is not equal to 0. So this is called the unit vector. We have already seen that. So therefore, unit vector along A is 1 by A times vector A, or we can just say vector A divided by its magnitude will give you the direction, will give you the unit vector along A. Okay, now let's look at addition of vector A plus B. Now let's say we have two vectors. Let's say we have a vector A and another vector B, and let's give names to these terminals, initial and terminal points. O A and B. Now here OA is equal to A, AB is equal to B. Now as far as adding this A and B basically tells us what is the starting point and what is the terminal point when we combine these two vectors. Remember, in such a case, what we need to do is, if a vector is in this direction and another vector in this direction, what we have to do is move it in such a way that it is not co-initial, but it is head to tail, right? So the vectors continue one on to the other. So here OB is equal to OA plus AB, or vector A plus vector B. Now this is also called the triangular law of addition of vectors. Now let's take it a little bit further. Let's say instead of taking it head to tail, or let's say we had this, right, the previous diagram, this is what we did. Now what we can do is we can create a parallel vector. Let's try to make it equal. Okay, and let's create a parallel here. Remember, this is O, A, B, C. Now here OA is equal to CB, and previously we had treated this as A and this as B. Now since OA is equal to CB, not only equal but parallel as well, because they are the sides, opposite sides of a parallelogram, right? So this is also vector A. Similarly, OC is equal to AB and OC is parallel to CB. So which means we have a parallelogram. This is also P. Now, since they are parallel, if we look at co-initial vectors OC and OA, then OC plus OA would be represented by the diagonal, yes, OB, yes. So whether you are choosing triangular law of addition of vectors or parallelogram law of, they both mean the same thing. Just remember, in case of triangular law, we are not talking of co-initial vectors, we are talking of head to tail, vectors being positioned head to tail. Whereas in case of parallelogram law of vectors, we are talking of co-initial vectors. So here this diagonal represents A plus B, A plus B. So, you might wonder, what does CA represent, right? So you have a parallelogram, you have one of the diagonals which is co-initial with these two vectors, representing addition of vectors. So what would CA represent? So CA would represent, so in case of the non-co-initial diagonal, it would represent subtraction of vectors AB. Just look at the previous diagram. AB plus CB, AB plus CB. Now here in this case they are coterminal, that means they end at the same point, is equal to CA. Now we can just change this to AC. So when we change CA to AC, what is happening? The direction is reversing. So which means AB plus CB plus AC is equal to 0. So you have a vector, you have another vector, a parallel vector. Let's make it longer, and we have this. This is A, this is B, and this would be A plus B, and this would be A minus B. That's what it boils down to. Okay, so this is one aspect of addition of vectors. Another aspect would be A minus B can be written as A plus minus B. Yes, so let's say this is O, A, B, C. So in triangle OCA, OA is equal to OC plus OCA. Which basically implies CA is equal to OA minus OC, which is equal to OA is nothing but A and OC is nothing but B. Just remember that OA, how did it become this? Because of triangular law. Just look at this. OC and CA are head to tail vectors, right? So when you add these two, you get the third side. So OA is equal to OC plus CA. Okay. If I have to sum it up, if A and B vectors represent two sides of a parallelogram, then the diagonals represent the sum and difference of A and B. So sum would be equal to co-initial diagonal. A minus B would be non-co-initial diagonal. Magnitude of vector A plus B, that is magnitude of the co-initial diagonal, is not equal to the sum of the magnitudes of these two vectors. And you can graphically really understand it. So let's say this is this, this is this. You know that this, which represents A plus B, is not equal to, right, the sum of A and B. So actually, if you think about it a little bit, it would be the magnitude of the sum of the vectors would be less than or equal to the sum of the individual magnitudes. Okay, now let's look at some properties of vector addition. A plus B is equal to B plus A. That means what? Commutative. A plus B plus C is equal to A plus B plus C. That means what? They are associative. Addition is associative. Third is, you have an element, that is the null vector. When you add this to any vector, you will get back the original vector. This is additive identity. A plus minus A is equal to 0. What is this? Opposites. Opposite of a given vector. So basically, when you look at this, you know that this is part of an abelian group. Okay, if you want to know what is abelian group, now you have to go back to group theory. And most importantly, or rather another point which is important, is that scalar multiplication can be distributive over vectors. So A plus B multiplied by M is equal to M multiplied by A and M multiplied by B, which means distributive property. So that is addition of vector. Bye for now.